Hey there, in this video, I'll be going over another set of problems. These problems will be on limiting reactants. Let's go ahead and take a look at our first problem here. Looking at the model below, identify the limiting reactant, the excess reactant, and how many molecules are in excess. So we are provided with the chemical reaction down here, which is very important in understanding, right? But realistically, we don't even need to look at our chemical reaction because according to this diagram here, or this picture, we know that each product, or really, let me rewrite that. One molecule for every product consists of one atom of nitrogen and 3 atoms of hydrogen, right? And we see that with the one blue circle here and the 3 clear circles. So the dark blue circles really represent the atoms of nitrogen, right? Because for every molecule of product, we have one blue circle, right? So that represents the one atom of nitrogen. So we know that these here are for nitrogen. And since for every one molecule of product, you have 3 of these little clear circles, those are going to represent the 3 atoms of hydrogen. Now, when you're sort of evaluating which molecules are in excess, it's very easy because you just look at your diagram here. Go ahead and identify that you only have 2 little atoms here that are not in a molecule. So those are said to be in excess, right? Because they're just there. They were left over. So since those are the 2 little circles that are in excess and those are clear circles, we know that the excess reactant is hydrogen. Hence, the limiting reactant in this case is nitrogen. And we are also asked for the number of molecules that are in excess. We have 1 molecule of hydrogen in excess, right? Because 1 molecule of hydrogen consists of 2 atoms of hydrogen. So, if I erase this here, you'll see more clearly. You have 2 atoms of hydrogen here, which is essentially, since hydrogen is diatomic, 1 molecule. So our number of molecules in excess equals 1 molecule of hydrogen. And this here is our answer for this problem. It's a fairly simple problem. Let's go ahead and take a look at problem number 2 here. It reads, draw the product, include the molecules that are in excess, and identify the limiting and excess reactant. So according to this model, right, for every 1 molecule of H2O, we have 2 atoms of hydrogen, and we have 1 atom of oxygen. Now this allows us to do an easy drawing of the product molecules, right? It allows us to do it very easily because I should mention that these represent the hydrogen atoms and these represent the oxygen atoms, right? Now, we only have 1, 2, 3, 4, 5, 6, 7, 8 atoms of hydrogen, and we have 6 atoms of oxygen, right? Now remember that for every 1 atom of oxygen in a water molecule, for every 1 atom of oxygen, you have 2 atoms of hydrogen, right? So if we have 1, 2, 3, 4, 5, 6 atoms of oxygen, we essentially need to multiply that by 2, and you get an answer of 12. So we need 12 really atoms of hydrogen in order to be able to make a clean reaction here, but we don't have those 12 atoms. We only have 8. So we're going to be forced to draw only 4 atoms. Watch. This is the reason why. Watch. So here I got rid of 2 of these and I got rid of 1 of these, okay? That's 1 atom of water. 1 molecule of water. Now we're going to go ahead and draw a second. A second. This represents a second molecule of water. Now we can go ahead and once again cross out 2 more of these and 1 of these. We're going to go ahead and draw another one. This represents another water molecule, and we'll draw 1 more water molecule. So we used up 2 more of these, right? 1, 2, because it was 1 for each of these. And then we used up 1, 2, 3, 4 of these, right? Because it's 2 per water molecule. So we're essentially now out of hydrogen atoms. But we still have 2 oxygen atoms remaining on the reactant side. So we go ahead and just fill those in here as clear atoms. Now these 2 atoms, or this molecule, sorry, let me color code that better. Those are supposed to be red. These 2 oxygen atoms, which represent a molecule of oxygen, are really the excess in this chemical reaction because they remained unreacted in this reaction. Now let's go ahead and take a look at what the problem was asking for in the first place. It says to identify the limiting and excess reactant. Now, since we have left over 2 atoms of oxygen, that makes oxygen our excess reactant. And since essentially the number of hydrogen atoms, right? We only had 8 in this case. Since the number of hydrogen atoms dictated the number of water molecules produced here, that makes hydrogen the limiting reactant in this particular problem. And this is how you solve this problem using this model. Let's go ahead and do this next problem. The Haber process combines nitrogen from the air with hydrogen from methane into ammonia. If 50 grams of hydrogen and 50 grams of nitrogen react, how many moles of ammonia would be produced? So this is a limiting reaction problem once again, and we know that because we are provided with 2 different starting values, and those are so we're provided with the 2 different values of the two different reactants for this chemical reaction. So the first thing that we have to do is just go ahead and write this out. We're provided with 50 grams of hydrogen and also 50 grams of nitrogen, right? Those are our starting values. And we know that we have to convert both of these to moles of ammonia, right? So I'm going to convert the hydrogen first. So we have to convert essentially from grams of hydrogen to moles of hydrogen first, because we are doing a substance conversion. So for every 1 mole of hydrogen, we have 2.02 grams of hydrogen, right? That's the molar mass of diatomic hydrogen. And then we convert from moles of hydrogen to moles of NH3, which is ammonia. Now, this conversion involves just looking at the chemical reaction here. For every 3 moles of hydrogen, you have 2 moles of ammonia. And now that allows us to do the conversion. Oh, sorry, no, that actually concludes that. So this is a setup for the conversion of the conversion from grams of hydrogen to moles of ammonia. Now let's go ahead and do the setup for nitrogen. So the first step is going to be to convert from grams of nitrogen to moles of nitrogen. For every 1 mole of nitrogen, you have, sorry, let me add that. It's nitrogen is diatomic, remember that? So when you take the molar mass, make sure that the molar mass is for diatomic nitrogen, and the molar mass should be 28.02 for every 1 mole of nitrogen. Now that allows us to do a conversion from moles of nitrogen, so moles of N2 to moles of NH3, right? To moles of ammonia. And once again, in order to do this, you just go ahead and look at this now. For every 1 mole of nitrogen, you have 2 moles of ammonia. And so this is a problem set up for this one now too. Now when you plug the first one here into your calculator for hydrogen, I would just ignore this one. So I would do 50 divided by 2.02. Then go ahead and multiply that by 2 over 3. Make sure you use your parentheses carefully when you plug that into your calculator. And your answer for this first one here should be 16.5 moles of ammonia, okay? And for your second answer here, I would go ahead and ignore these ones once again. So I would do 50 grams of nitrogen divided by 28.02. Then go ahead and just multiply that by 2, right? Because we ignore this one. So I just multiply that by 2. Then I would go ahead and get an answer of 3.59 moles of ammonia. Sorry, this should have had a 3 of ammonia. So now we have 2 values of ammonia that could be produced, right? Because that is what 50 grams of hydrogen would produce up here. And down here is what 50 grams of nitrogen would produce. And those are both reactants in this chemical reaction. Now, since for every 50 grams of nitrogen, you can only produce 3.59 moles of ammonia. That is the limiting reactant. Nitrogen in this problem makes for the limiting reactant because it can produce fewer number of moles of product. And so the real number of moles of ammonia that would be produced in this particular chemical reaction is 3.59. So I'm going to box this in just several more times because this is the correct answer here. This was the limiting reactant, nitrogen. So that made the number of moles of product that nitrogen could produce the real number of moles that could be produced, because everything else here will just be in excess. And so that is the number of moles of ammonia that would be produced given that 50 grams of hydrogen and 50 grams of nitrogen were to react. This is going to be the last problem of this limiting reactant video. So let's go ahead and take a look at the problem. During the synthesis of water, 25 grams of hydrogen reacted with 35 grams of oxygen. How many grams of water was produced? Identify the excess reagent and how many moles is unreacted. So we're asked for several different things, and I sort of want to break this down. And I want to start by just writing down the chemical reaction that we're dealing with here, and it's the synthesis of water. So it's H2 plus O2, and H2O is being produced, right? And the balanced reaction puts a coefficient of 2 in front of the H2O and a coefficient of 2 in front of the hydrogen. So this is the balanced reaction now. I'm actually going to just box this in for this reaction that we're dealing with. Now, I want to also start off by just writing the values that we are presented with, or that we are given to start off. We are given 25.0 grams of hydrogen and 35.0 grams of oxygen. And we are asked how many grams of water was produced. In order to find out how many grams of water were produced, we need to first figure out what our limiting reactant is. And from there, we'll be able to truly grasp onto an accurate idea of the number of moles first of water that are produced. And that sounds confusing, but really we're just going to convert the grams of both of these reactants to moles of product. So let's go ahead and get started with hydrogen here. So let's convert grams of hydrogen. You know what? Let me do that a different color. I'm sorry about that. Let's convert grams of hydrogen to moles of hydrogen. For every 1 mole of H2, you have 2.02 grams of H2. That's the molar mass of hydrogen in its diatomic form. And now let's convert moles of hydrogen to moles of H2O. For every 2 moles of hydrogen, you have 2 moles of H2O, according to our balanced chemical reaction, right? And so this is the problem set up in its complete form for the conversion from 25 grams of hydrogen to moles of water. Sorry about that. And so now let's go ahead and do the conversion for the 35 grams of oxygen. Now, in order to convert the 35 grams of oxygen to moles, once again, we'll be doing a conversion from grams of oxygen to moles of oxygen first. For every 1 mole of oxygen, you have 32 grams of oxygen, because 32 is the molar mass of oxygen in its diatomic form. And then we do, once again, the same conversion, not the same, but the similar conversion in which we convert from mole to mole, right? And so we'll be doing moles of O2. In this case, we're converting from moles of O2 to moles of H2O. Now, according to this, sorry about that. Actually, I circled the wrong one. For every 1 mole of O2, you have 2 moles of H2O, according to our balanced chemical reaction up on top. And so now this completes the setup for this second one. Now, for the first one here, what I would do if I plug this into my calculator, the 25 grams conversion of hydrogen, I would actually just ignore this here because the 2's get canceled out, and I would ignore this 1. And what I would do is just go ahead and plug in 25.0 into my calculator and go ahead and divide that by 2.02, and you should get your answer that way. And your answer should actually be 12.4 moles of H2O. And for this second one here, for oxygen, I would go ahead and cross out the 1's, right, just for clarity. And I would plug in 35.0 into my calculator, go ahead and divide that by 32. And once you get that answer, I'd go ahead and multiply that by 2. And you should get your answer that way, a correct answer. And you should get 2.19 moles of H2O. And what these two answers tell us is that given these two starting number of grams for our reactant, these are the number of moles that are produced, right? And so according to these answers, we can only produce 2.19 moles of H2O because oxygen, according to these answers, right, this is demonstrative of that. The fact that we can only produce 2.19 moles of H2O because of oxygen instead of the 12.4 moles of H2O that the hydrogen can produce, that makes oxygen our limiting reactant. And so since oxygen is our limiting reactant, we can now go ahead and convert the 2.19 moles of H2O, right, to grams of H2O, because oxygen is our limiting reactant. Therefore, oxygen is going to dictate the number of grams of H2O that can be produced. And so for that reason, we now convert H2O, moles of H2O, So I'll be converting moles of H2O to grams of H2O. And this is, again, a simple conversion in which you do 1 mole and then the molar mass of H2O, right? For every 1 mole of H2O, you have 18.02 grams of H2O. That's the molar mass of H2O. And so your answer for this should be 39.4 grams of H2O. This is the number of grams that are produced when 25 grams of hydrogen react with 35 grams of oxygen, right? When we take into consideration our limiting reactant and our excess reactant, this is the number of grams of hydrogen, of water that is produced. Now, we are also asked for the number of moles that unreacted. Now, we know that 2.19 is the number of moles that are produced, right? Because our limiting reactant is oxygen, and oxygen produced 2.19 moles of H2O. Now, hydrogen produced 12.4 moles of H2O, however. So that means that hydrogen produced excess H2O. Now, knowing that, we can go ahead and do a simple subtraction problem and subtract and do 12.4 minus 2.19, right? The 12.4 I got from here and the 2.19 I got from here. Once you do this, you should be getting an answer of, let me plug this into my calculator to not get an incorrect answer and get confused with all the numbers here. You should be getting an answer of 10.21 moles. So 10.21 moles remains unreacted, and these 10.21 moles are moles of hydrogen, right? Because hydrogen, once again, was our excess reagent. So we did number 1. We identified our excess reagent. We also identified the number of moles of hydrogen that are in excess. And we also identified the number of grams that are produced when 25 grams of hydrogen and 35 grams of oxygen react. And so we actually completed this problem. It was a pretty complex problem, but it's actually fairly simple once you understand the concept of limiting reactants and excess reactants and how they sort of interact with each other and how they're able to produce different numbers of product according to the number of reactants that you have. And so this is how you do this problem. I hope you understood the concept of limiting reactant throughout this video better, little by little. And I hope that you're able to learn through these problems as well. Thank you so much for listening. Have a great rest of your day.